Okay, so today we're going to continue our discussion of function relationships, and the first thing we're going to look at is determining intervals on which a function is increasing or decreasing. Well, what do we know up to this point about when a function is increasing or decreasing? Let's think back to limits, probably not super helpful, but maybe derivatives. So what is happening on a derivative? Like if I have some function that looks like, I don't know, boo, 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 this, okay? What is happening on my derivative right here? My function is increasing here, then it goes decreasing, then back to increasing. Right here, if I were to draw a tangent line, okay, right here, my tangent line, what do you notice about the slope? It's positive, whereas over here my slope is negative, and then over here it's positive. In between it goes through 0, okay? But basically if I can determine where my where my derivative is positive or negative, then I can determine where my function is increasing or decreasing. So that's what we're going to do today. So to get us started, let's see here. We've got the function f of x equals 1/3 x cubed, blah, blah, blah. So we have a cubic function, and I know that in order for my function to be increasing, f of x is increasing when f prime of x is positive, okay, and I know that it's decreasing when f prime of x is negative. So I want to try to find the intervals for where this is occurring. Well, if I know that I want to find positive and negative, I need to determine where it crosses that fine line between positive and negative. And that's whenever your function derivative is equal to 0. So whenever my derivative is equal to 0, then I can maybe determine what's happening on either sides of those points. So let's start out with our derivative. So f prime of x is equal to, let's see, x squared minus 2x minus 3. I'm going to set that equal to 0. So I'm going to factor this. Oh, it's our favorite. Everybody loves to factor. Minus 3 plus 1. So it looks like f prime of x is equal to 0 when x is equal to 3 and negative 1. Okay, so prime of x equals 0 when x equals 3. Ooh, does anyone remember from 2 videos ago what these numbers are called? When the derivative is equal to 0 at a specific number, these are our critical numbers. Ooh, what else does sometimes happen at a critical number? Not always, but sometimes they could be relative extrema. Relative extrema always occur at critical numbers, but critical numbers aren't always relative extrema. Okay? So to figure out what's happening in between, like right now, I need to figure out where my derivative is positive and negative, but all I know is where it's exactly equal to 0. So what I like to do is I like to make a little number chart here. Let's see, so I'm going from negative infinity to negative 1. I know what's happening at negative 1, and I've got negative 1 to 3, and from at 3, I know what's happening, and I don't know what's happening from 3 to infinity. Okay, so the reason I made this chart is I'm trying to figure out what is happening on my derivative in these intervals. I mean, this isn't really an interval. I know my derivative is equal to 0 here and here. We've already determined that up above. But what I need to do is figure out what's happening in between. So I'm going to pick an arbitrary number in the interval. I like to go with the simplest one possible, so let's go with negative 2 here. So what is f prime of negative 2? F prime of negative 2, again, I like to make things easy as possible, so this is already nice and factored. Well, negative 2 minus 3 is negative 5, so it's a negative. Negative 2 plus 1 is going to be another negative. So negative times a negative is a positive. So my derivative is positive here, okay? Let's go to this interval from negative 1 to 3. Let's go with 0. What's f prime of 0? I don't necessarily care what the value of it is. I just care, is it positive or negative? 0 minus 3 is a negative. 0 plus 1 is a positive. A negative times a positive is going to be a negative. So that means my derivative is negative from -1 to 3. From 3 to infinity. So f prime, let's go with just 4. 4 minus 3 is going to be a positive. 4 plus 1 is positive. So positive times positive is another positive. So my derivative is negative. I'm sorry, it's positive right here. It's exactly 0 at -1. It changes to negative from -1 to 3. It's 0 at 3, and it goes back to positive. Because I know this, then I can also determine where my function is increasing or decreasing. So then so this is what's happening on f prime of x. If I know what's happening on f prime of x, then I can determine what's happening on f of x. If f of x is positive, if f prime is positive, that means f of x is increasing. If f prime of x is negative, that means f of x is decreasing. And then we're back to, oops, oh, it's doing its little thing again. See if I can get that to stop doing that. Decreasing, nope. Hang on. When in doubt, grab the other pen. Let's see. Nope, hang on, wait for it. Decreasing, and then increasing. So then the actual question was, what are the intervals where the function is increasing and decreasing? So off to the side, I'm going to say f of x is increasing on the interval from -infinity to -1 union 3 to infinity, because it's doing it on both of these intervals, okay? And I know that it's increasing because f prime of x is positive here. And then f of x is decreasing on the interval from -1 to 3 because f prime of x is negative on that interval. Okay? So that is how we determined the intervals for when our original function is increasing and decreasing. I'm going to give you another example. This is another one of those opportunities where I want you to pause the video, try this on your own, and then come back after you've had a chance to give it a try. Okay? So I'm hoping you actually did that. So let's go ahead and get started here. Intervals of increasing, decreasing. So I'm going to start with my derivative, just like we did on the last problem. So f prime of x is -3x squared minus 3x. Okay, set this equal to 0. I'm going to factor out -3x from both parts, so then I'm going to be left with x plus 1. So then x is equal to 0 and -1. That is where my derivative is equal to 0. Okay, so if my derivative is equal to 0, let's go ahead and, again, remember that means these are our critical numbers. All right, so let's go ahead and make our intervals. So I'm going to go from -infinity to -1. I know what's happening at -1. I'm going to go from -1 to 0. I know exactly what's happening at 0. And then I'm going to go again from 0 to infinity. So I'm going to cover the entire real line, okay? Every number, since this is a continuous function, I want to make sure every number on this function is accounted for. And this essentially covers negative to positive infinity. I just have little stopping points at -1 and 0 because that's where my derivative is equal to 0. So let's talk about f prime of x. Let's see. I know it's 0 here and here, okay? So I'm going to plug in, let's go with -2. F prime of -2, so f prime of -2. So -3 times -2 is going to make positive 6. -2 plus 1 is going to be a negative, so positive times a negative is going to be a negative. Okay, and then from -1 to 0, I guess we'll do f prime of 1/2. Again, don't be afraid of fractions. Fractions are friends, not food. Always remember that. Positive. So -3 times positive 1/2 is going to be a negative. Positive plus a positive here is going to be a positive. So negative times a positive is going to be a negative. Wait a minute. My notes say that that's positive. Oh, that's because I used positive 1/2, guys. That's not right because we're going from -1 to 0. How about we use -1/2? That makes a little bit more sense. Negative times a negative. That's positive. -1/2 plus 1, well, that does give us a positive. So positive times positive, positive. I am positive we are right this time. Oh, I cracked myself up. Okay, this time if I wanted to, I could use positive 1/2, but please, let's just go with 1. F prime of 1. Negative 3 times positive 1, that's negative. No. Positive 1 plus 1, that's positive. So positive times a negative is a negative. Okay, so because I know what's happening on my derivative, now I can determine my intervals of my increasing and decreasing for my function. So f of x is increasing wherever my derivative was positive, and that's going to be from -1 to 0, because f prime of x is positive, and then f of x is decreasing on 2 intervals. Let me give myself a little more space here. Let's say from -infinity to -1 union 0 to infinity, because f prime of x is negative. Okay, so again, check your answers. Hopefully that matches mine. If not, go back, try it again. See what happened here. Okay, so graphically, what is happening at the critical numbers for the previous 2 functions? And the critical numbers, remember, that's where f prime of x, for all the 2 functions we just did, we only had the situation where f prime of x was equal to 0. Remember, critical numbers is where f prime of x is equal to 0, or technically it's also where f prime of x does not exist. We just didn't have that situation for the last 2 functions. The only situation we had for the last 2 functions was this guy right here, that f prime of x is equal to 0. Okay, so graphically, what's happening? Think about it. Pause the video, write some stuff down, come back and check. When f prime of x is equal to 0, you've got a horizontal tangent. Okay, because your slope, the slope of your tangent line, is equal to 0. Okay, in both of the last 2 questions we had, f prime of x changed signs. Okay, now that was unique to these 2, the last 2 functions. So I'm going to put a little star right here. Sometimes it happens. It doesn't always happen. Okay, it just happened. It just did for these 2 functions, and that's what they're asking about. Okay, with that, because this is changing signs, f of x changes from increasing to decreasing and vice versa. Okay, so if we think about graphically, if our function is changing from increasing to decreasing or vice versa, what's happening, and we have horizontal tangents here and here, what else is happening at these 2 critical numbers? We have relative extrema. Okay, and this particular, the one I drew right here, they're not absolute extrema because I have graphs, but it could go up to here and goes down to here. So I wouldn't have an absolute min or max, but I have a relative max and a relative min right here. Okay, so if I can look at where my function changes from, where my function has a horizontal tangent, where my derivative changes from positive to negative or vice versa, and my function changes from increasing to decreasing or vice versa, then that helps me determine the locations of my relative extrema. Okay, I could further go into finding my absolutes, but right now we just want to talk about relative extrema. Okay, so using the intervals of increasing and decreasing that we found earlier, determine the relative extrema for the following function. So the intervals that we had earlier were from negative infinity to -1, and then I had -1, I knew my derivative was equal to 0, and then I had from -1 to 3, 3, and then 3 to infinity. Okay, oh, my derivative was 0 here. So then f prime, and let's talk about what's happening on f. Okay, so we said that this was positive, negative, positive, okay, which meant graphically my function was increasing, decreasing, and then increasing. I don't actually know for sure how steep the increase and decrease is. I just know that my graph changes from increasing here to decreasing on this interval back to increasing here. So if my graph is doing that, what has to be happening in between? Here you have to have a relative maximum, okay? As opposed to over here, you would have a relative minimum, okay? Because my function is changing from increasing to decreasing, and then again back to increasing. I know that I have a relative maximum and a relative minimum here. Now these are the x values to determine the actual relative extrema. I like to know where they occur, meaning I need to know my x and y coordinates. So let's plug these in. Let's find what is f of -1. So 1/3 -1 cubed minus -1 squared. I jumped ahead there, but -3 times -1 plus 2. So you're going to have 1/3 -1 plus 3 plus 2. I'm going to do some fancy math here and tell you that that's 11/3. And then f of 3 is going to be 1/3. 3 cubed minus 3 squared minus 3 times 3 plus 2. And that is going to be -7. So I know I have a relative maximum at -1, -7, and at 3, 11, I'm sorry, at -1, 11/3, I have a relative maximum, but at 3, -7, I have a relative minimum. Okay, so here's the write-up that we want to write. F of x has a relative, just because -1 is listed first, I'll go with that. Relative maximum at -1, 11/3. And I know this because f prime of -1 equals 0, and f prime of x changes from positive to negative. With that, that means that the function itself changes from increasing to decreasing. You only really need to write one. I would actually just leave it as going off of the derivative, because that's really where all of this started from. These are the conclusions I made knowing what my derivative was. F of x has a relative minimum at 3, -7, because f prime of 3 equals 0, and f prime of x changes from negative to positive. Okay, what I have done with each of these explanations, I've answered the question, has a relative max at this location. I need to also justify how I know that. So the first part is, how do I know -1 is a critical number? -1 is a critical number because the derivative is equal to 0, -1. And then I specified how I know that it's a relative maximum. That's because my derivative changed from positive to negative. I know that if it changes from negative to positive, it's a relative minimum, and that's what I have down here for 3, -7. Okay, I hope that makes sense. Let's clarify some more on the next one. Okay, so again, going back to the same problem, the second problem we did earlier today, let's look at those intervals again one more time. So we had from -infinity to -1, then you had -1, then you went from -1 to 0, 0, and then 0 to infinity. Okay, this is looking at the derivative. We knew that the derivative was negative here, 0, positive, 0, and negative, which means if I want to follow the same pattern we did on the last problem, okay, wherever the derivative was positive, f was increasing, so I've got increasing, decreasing, decreasing. So if f of x, whoa, I don't know where that line came from. F of x, that means it's decreasing, increasing, decreasing. Okay, if that's the case, then I know I have a relative min here and I have a relative maximum over here. So I just need to determine my x value, or sorry, I have the x values. I need to determine the y values for each of those. So I need to find what is f of negative 1, negative of negative 1 cubed minus 3 halves times, that's a half, negative 1 squared. That's going to be negative 1/2. And f of 0, oh, well, that works out really nicely to just be 0. So, again, I'm just going in order from left to right. What's listed first? I have a relative minimum, so I'm going to say f of x has a relative minimum at negative 1, negative 1/2. Because f prime of negative 1 equals 0, and f prime of x changes from negative to positive at that specific value, okay? And then f of x has a relative maximum at 0, 0, because f prime of 0 is equal to 0, and f prime of x changes from positive to negative, okay? In the event that the derivative does not exist, and that is what determines your critical numbers, that's what you would write here. Instead of saying that f prime of negative 1 is equal to 0, you would say f prime of negative 1 does not exist. That's my justification that negative 1 is a critical number. I have to specify why I even look at numbers negative 1 and 0 on my function of where my intervals changes from increasing to decreasing. And I do that because they're critical numbers. Why are they critical numbers? In this case, it's because the derivative is equal to 0. But it's not always going to be that case. Okay? All of this, all combined, gives us what is called the first derivative test. There's going to be a lot of words on this page. I highly, highly recommend that you write this down, okay? Writing it down really helps solidify it in the brain, okay? Whoops, not there. I want to grab right here. So let C be a critical number of a function f that is continuous on an open interval. That's pretty straightforward. We know what that means, okay? On an open interval I containing C, if f is differentiable on the open interval except possibly at C, again, if it's not differentiable at C, ooh, what does it make it? That makes it a critical number, just at C, okay? So if f is differentiable on the open interval except possibly at C, then f of C can be classified as follows, okay? It can be a couple of different things. The first thing, if f prime changes from negative to positive, then f has a relative minimum at C f of C. Okay, we just did that. We looked where the derivative changed from negative to positive. We determined that the function itself changes from decreasing to increasing, which means you have a relative minimum. I think I have a graph. Oh, look, there's a lovely little graph of that right there. My derivative changes from negative to positive. My function changes from decreasing to increasing, relative minimum. The opposite of that would be if, oh, I have a, let's move that. Here we go. If f of x changes from positive to negative at C, okay, then f has a relative maximum. So it's going the opposite direction. Derivative change from positive to negative, you have a relative maximum. Okay? Is there a third option? Of course there is. If f prime is positive on both sides or negative on both sides, then f of C is neither a relative min nor a relative max. So if I have this situation, okay, I still have a horizontal tangent here. I still have a horizontal tangent here. F prime of C is still equal to 0. These are still critical numbers. However, my derivative is positive or negative on both sides. That means my function is increasing or decreasing on both sides. So therefore, there's no relative min or maximum. There are critical numbers. There's one here and there's one here, or critical points, I should say, at your critical numbers. But there's no relative min or max in this situation because basically your increasing and decreasing has to actually change, and it doesn't change here. Okay? So I want you to pause the video and find the relative extrema for this particular function. Okay? I will work through it, but I want you to try it on your own first. Okay? Okay, so I hope you actually paused the video and tried this on your own. Let's go ahead and make sure that we all know what we're doing. So to find the relative extrema, the first thing I always have to do is take the derivative. So f prime of x is going to be 2/3 x squared minus 4 to the negative 1/3 times the derivative of the inside, so 2x. A good opportunity to use chain rule here. If I clean this up a little bit, this is going to be 4x over 3 times x squared minus 4 to the 1/3. Okay, so for my critical numbers, I need to check both ways in this case. So critical numbers, I could have f prime of x equals 0. So f prime of x is equal to 0 basically whenever my numerator is equal to 0. So 0 equals 4x, so x is equal to 0. This is my first critical number. I also need to check for where f prime of x does not exist or is undefined. Slash is undefined. Okay. In this case, because I have a fraction, I need to look at my denominator. So whenever my denominator is equal to 0, that's when my derivative, my entire derivative function, would not exist. So I just need to look at where x squared minus 4 to the 1/3 is equal to 0. Well, you cube both sides, you still get x squared minus 4 equals 0. That's going to be x squared is 4, so x is equal to plus and minus 2. It is vitally important that you always remember this plus and minus, guys. We learned about this a lot in Algebra 2. It's going to come back to haunt you if you forget to do that. Okay, so now I have three critical numbers, 0, negative, and positive 2. So let's make our chart. So I'm going to go from negative infinity to negative 2, from negative 2 to 0, 0, 0 to 2, 2, and then 2 to infinity and beyond. Okay, so my derivative. Let's talk about what's happening on the derivative. I'm going to plug in f prime of negative 3. F prime of negative 3. This one's a little bit more difficult. Well, I know that it's got to be negative in the numerator, okay, because the negative 3 times 4, that's going to be a negative. Let's see, negative 3 squared. Negative 3 squared is 9. 9 minus 4 is positive 5. So even if I take the cube root, it's going to be a positive. So I have a negative divided by a positive, so that's going to be a negative. Okay. Oh, I already know that at negative 2, I don't want to write 0 now. I want to say does not exist because my derivative does not exist at negative 2. Up until this point, we've always been able to put a 0 right here. No longer the case, folks. No longer the case. Now we're plugging in the fact that it does not exist. That's what's making it a critical number. Let's go with f prime of negative 1. Again, I'm going to have a negative up top. This time, 1 squared, or negative 1 squared, is going to be 1, minus 4 is a negative 3. The cube root of a negative number, I have no idea what that number is, but I do know that it's negative. So a negative divided by a negative is going to be a positive. Okay, I know that at 0, my derivative was equal to 0. That's what classified it as a critical number. From 0 to 2, let's go with positive 1. So f prime of 1. I'm going to have a positive up top, but then this is going to be a negative in the denominator. So positive divided by negative is going to be a negative. At 2, my derivative does not exist. It is undefined. And then from 2 to infinity, let's go with f prime of 3. I'll have a positive up top. Then I'll have another positive in the numerator. So it's going to be, I'm sorry, in the denominator. So it's going to be positive overall. Okay, so we're looking for relative. Now this time I didn't want let's see, what are they asking? Relative extrema. So they don't necessarily need to know intervals of increasing and decreasing. They just want to know where the derivative changes from positive to negative. So here, my derivative changed from negative to positive. So that means on f of x, this is going to be a relative, I don't know what that word is. Minimum. That's what it's supposed to be. This is going to be a relative min. Okay, I want to specify relative because I don't know that it's the absolute. Okay, so that's a relative minimum. Okay, my derivative changes from positive to negative here. Okay, so that means this is a relative maximum on my function. And then it changed from negative to positive over here, so this is another relative minimum. So I have two relative minimums and one relative maximum. Okay, again, that's allowed. Nothing wrong with that. But oh shoot, I have to know where. I need to know my coordinates. So let's see, I need to find f of negative 2. I need f of 0 and f of 2. I already forgot what the function was. F of x is x squared minus 4 to the 2/3. So negative 2 squared minus 4 to the 2/3. Oh, that's nice and easy. That's just going to be 0. Oh, and that makes this one also 0. 0 squared minus 4 to the 2/3. So for this one, you've got negative, that goes away. Negative 4, you want to square it and then take the cube root. Actually, it doesn't really matter. It's going to be a really gross number anyway. You're just going to leave that as, let's see, 4 squared is 16 cube root. You could write this a couple of different ways. I like to write this as, let me think about this, 2 cube root 2. Because 2 times 2 times 2, well, this works out to be cube root of 16, right? You can take out part of it. You can take out the cube root, like 2 times 8 is 16. So the cube root of 8 is 2, so you bring that out, and then you have 2 left over. Okay? All right. So f of x has a relative minimum at negative 2, 0, and 2, 0, because f prime of negative 2 and f prime of 2 does not exist, and f prime of x changes from negative to positive. Okay, f of x has a relative maximum at 0, 2 cube root 2, or you could just leave that as the cube root, or the cube root of negative, the cube root of 16. Either one's fine. It's all good, guys. That almost looks like a 23. But that's not what I want. Make that 2 a little bit bigger. There we go. Because this time, it's not the same reason, f prime of 0 equals 0, and f prime of x changes from positive to negative. Okay? So those are the relative extrema for that fun, crazy problem. Let's see about another one. Okay? Ooh, same idea. Ooh, but we want relative and absolute extrema. Okay? Again, pause the video, give it a try on your own, come back, check your answers, see what you got here. So, welcome back, assuming you paused it. Let's start with our derivative. Derivative of sine is cosine. Derivative of cosine is negative sine. I'm going to set this equal to 0. So cosine x minus sine of x. Just move the sine of x over. Where is sine of x equal to cosine x, guys? No, you don't need a calculator for this. You don't need a calculator for this. The only value where this is true from 0 to pi over 4, basically in the first two quadrants is going to be at x equals pi over 4. Okay, that is your only critical number for this problem. Because is there a place where f of x is undefined? What do you think? That's cosine minus sine. Continuous function. Continuous function. None. So you're good to go there. Okay? So then, because I want to find relative and absolute extrema here, when I make my intervals, they gave you the n values. So when you're making your chart like we normally do, you don't have to go all the way to negative and positive infinity. You can start at 0, stop at pi over 4, talk about what's happening at pi over 4, and then go from pi over 4 to pi. Okay? Now, oops. Here we go. There we go. Let's see. F prime of x. Let's pick, I don't know, f prime of pi over 6. Let's see. Pi over 6, cosine of pi over 6 is root 3 over 2. Sine of pi over 6 is 1/2. I don't know that exact value, but I know that root 3 over 2 is greater than 1/2, so positive. F prime of x was equal to 0 at pi over 4. From pi over 4 to pi, I'll just pick pi over 2. It's pretty easy because cosine of pi over 2 is 0. Sine of pi over 2 is 1, but it's 0 minus 1, so it's negative 1, so this is negative. Okay, so that means since my derivative changing from positive to negative, that makes this value a relative, what do we got here? Relative maximum, positive to negative, okay? But we're not done here. We want to also know the absolute extrema. So let's go ahead and make our candidates test chart. So f of x, we've got 0. We've got pi over 4 and pi. I mean, I need to know where my relative maximum is anyway, but that's fine. So going back to my original function, sine of 0 is 0, cosine of 0 is 1, so that's 1. Sine of pi over 4 is root 2 over 2 plus cosine of pi over 4, which is also root 2 over 2. So root 2 over 2 plus root 2 over 2 is 2 root 2 over 2, which is just root 2. And then sine of pi again was 0, cosine of pi is negative 1, so negative 1 here. So we've got f f has a relative maximum at pi over 4 root 2 because f prime of pi over 4 equals 0 and f prime of x, nope, what am I doing? Changes from positive to negative. We also wanted the absolute extrema, so the absolute minimum of f is, let's see, between only one negative, so is negative 1 and occurs at pi comma negative 1. The absolute maximum of f is, all right, so you've got 1 versus root 2 over 2. Well, I'm going to tell you that the square root of 1 is 1, so then the square root of anything higher than that's got to be bigger than 1. So this is going to be your absolute maximum, is root 2, and occurs at pi over 4 root 2. Okay, notice in this case, your relative and absolute maximum were at the same place. That's okay. That's allowed to happen, okay? Sometimes they can be the same, but they don't always have to be the same, okay? So I have 2 more examples on this flip chart, but I'm going to go ahead. They're pretty straightforward. So I'm going to go ahead and like end the video here. I will post the answers to the next two examples on Canvas as I normally would. So you're welcome to try those out and then check your answers on your own. But I think I've already gone through a pretty good explanation of how to find your relative extrema based on what we like to call the first derivative test. So check those examples out. If you have questions, Prof. Rob Bob, Khan Academy, or check out your textbook.